let's look at how we would graph the sine of x, sine of an angle, theta, x, whatever we want to call it. So let's think about the values for the sine of an angle. If we're dealing with a unit circle, the highest value that we're ever going to get to is 1 because that's the largest coordinate in any of the coordinate points on the unit circle. So one thing that you need to know about the sine graph is that it only goes up to 1. And along the same reasoning, it actually is only going to go down to -1. So if I were to graph the sine of theta, since we deal with radians in trig most of the time, our x-axis is going to go by radians instead of degrees or regular coordinate points. So I have up here our angles up until pi. So let's think about evaluating what sine is at these points. So the sine of pi over 6 is 1/2. So I'm going to plot a point about 1/2. The sine of pi over 4 is the square root of 2 over 2, which as a decimal is about 0.707. So we're going up a little bit more. And the sine of pi over 3 is the square root of 3 over 2, which is 0.866. So we're not quite at 1 yet. The sine of pi over 2 is when we hit 1. And we have the angles 2 pi over 3 and 3 pi over 4 and 5 pi over 6. And they happen to have reference triangles that are pi over 3, pi over 4, and pi over 6. And in the second quadrant where these angles lay, second quadrant sine is positive. So they're actually going to have the same values. The sine of 2 pi over 3 is going to be the same as the pi over 3 sine. The sine of 3 pi over 4 is going to have 0.707, and the sine of 5 pi over 6 is going to be 1/2. So much so then, by the time we get to pi, the sine of pi is 0. Now, we only drew in the sine of the angles from 0 to pi. If we move on to the third and the fourth quadrants, sine now becomes negative, except for the values are going to be the same values. So if I extended this graph, I end up with a graph that's now going to be in the negative, but has the same values. So one full cycle from 0 to 2 pi all the way around, the sine graph is going to look like I just now. Obviously, we have the sine of all the angles in between our reference triangles that we had, the pi over 6 and pi over 4. There's lots of angles between them. So it will be a connected graph. Now, is this an entire graph of sine? No, because we could have coterminal angles that are going to, again, have the same values as the sine of pi over 6. The sine of 13 pi over 6 would be the same as the sine of pi over 6. So it's going to then create another cycle of it. So technically, the sine of pi goes on forever. So this is the one that we know, but it's going to do the same thing forever and ever and ever in both directions, because I could have had the negative of the angle as well. The highest value is going to be at 1, and the lowest value is going to be at -1. So the sine of graph always is going to start at 0 and go up. That's the way that I remember it. Sine starts at 0 and goes up.